This is section 7.1, part 2. What we are being asked to do is to figure out when this fraction is undefined, or what values make it undefined. To do that, we need to take r squared plus 5r plus 4 and set it equal to 0 and solve. Well, this is a quadratic because we have that square on there. And so what we have to do is what we were doing back in the last chapter. We need to factor this, and then we'll set each part equal to 0. So go back to your factoring chart. Do we have a GCF? No. We have 3 terms. Do we have squares on the ends? That's a square, that's a square. Let's do a quick check and see if it is. The square root of r squared is r. The square root of 4 is 2. If I multiply these together, I get 2r. If I double that, I get 4r, which is not the same as that. So it took a second, but it's not a perfect square trinomial. So we have to do what we did in section 6.2, which is where we look for 2 numbers that multiply to 4 and add to 5. Well, numbers that multiply to 4 are 1 and 4, and 2 and 2. And that's it. If I make both of these positive, they multiply to positive 5 and they multiply to positive 4 and add to positive 5. So this factors as r plus 1 times r plus 4, and that's still equal to 0. Now we use the zero factor property, set each of these equal to 0. And solve these. And so I need to subtract 1 from each side, and I get r equals -1. Subtract 4 from each side, and you get r equals -4. So the numbers that must be that make it undefined are right here. If I plug in either one of these numbers, I'm getting a 0 in the bottom. And remember, it doesn't really matter if we have a 0 on the top. That's why we're not paying attention up here. It's only the bottom that causes us problems. If you were asked to write your answer in this set notation, what it would look like is the set of all r, and it's r this time because that's our variable, such that r does not equal -1, -4. You just put a comma between the things that have to be excluded. Like I said, I don't think you're going to see that. All right, let's try this one. Figure out what makes this undefined. So I would need to take my denominator, q squared plus 9, and set it equal to 0. Well, this is a quadratic, so let's see if we can factor it. I do not have a GCF. I have 2 terms, so I check for a difference of squares. Well, one of the requirements for a difference of squares is to have a difference. We have a plus there, not a minus. So this is not a difference of squares. Okay, so we can't factor this. In fact, this thing is never equal to 0. Let me go one step here and see if I can convince you that this is true. Imagine moving this over to here. So let's subtract 9 from each side. And that gives me q squared equal to -9. Well, this is saying if I square something, I get a negative number. There's no way for that to happen. If I square a positive number, that's 2 positive multiplied together, and I get a positive answer. If I'm squaring a negative number, that's a negative times a negative, and I get a positive answer. This cannot happen. Since where this thing is undefined is where this equals 0, since this cannot equal 0, this thing is never undefined. We can plug in any number in there and it's going to be a legitimate answer.